All right, ladies and gentlemen, let's get started here today. We are graphing with intercepts today, and we kind of did this a little bit in the last video where we were going to be plugging in numbers, and I showed a quick example there at the end about how we can do it with intercepts. We're going to do, just going to do it more algebraically today, and with that specific purpose. Okay. We're also going to do an in context thing. So we kind of understand exactly what we're looking at when we are, what it means, okay? Just make it figure eights. Sorry, got distracted. So let's just jump right in. Some things to add to your vocabulary. Right, you're going to want to pause the video here and add these to your vocabulary form online. We've got three things. The X-Intercept, which we talked about yesterday. The X-coordinate of a point where a graph crosses the X-axis. If we wanted a little picture of this, right? This here is the X-axis, and this point right here is the X-intercept. It's the point where it crossed the X-axis. We call it the X-intercept. We find that algebraically by substituting in 0 for the Y-coordinate. The Y-intercept is the opposite. It is that point where it crosses the y-axis, right? Because the vertical one is the y-axis. And we plug that in, or excuse me, we find that by plugging in, substituting in for the x-coordinate. So here we're going to have the x-axis with 0 for y, and down here we're going to have 0 for x with the y-coordinate. The x-intercept crosses the x-axis. It's a 0 for y. The x-coordinate is 0. The y-intercept is the 0 for x. Finally, we have this last thing. It's called standard form, and I really should say standard form of a linear equation, just so that we are absolutely clear. And standard form here is when we have something that looks like this. You did problems like this yesterday. Some examples of standard form would be x plus 3y equals 4, or 3x minus 2y equals 6. Those are them things in standard form. Some non-examples would be y equals 3x plus 2, right? That is a non-example. Or 3x equals y minus 1. That's another excellent non-example because it is not substitute form. Notice the form here, right? An x term plus or minus a y term equals some constant, okay? These are examples. These are non-examples. I should have done the non-examples in red, right? Those are bad. Not the same thing. This is working well because it's at the bottom. Okay, good. So make sure you have those added to your algebra vocabulary, and let's move on. We're going to find the intercepts algebraically. So we're not going to worry about graphing at first. We're just going to do this algebraically. So we remember what we said. The x-intercept, we're going to sub 0 for y. So I'm going to take 0 and I'm going to sub it in for the y here. So that's going to be 2x plus 7 times 0 equals 28. That just becomes 0. So it's we can kind of get rid of it, right? It goes away. And so this is 2x equals 28, excuse me. And then we're going to finish solving this equation to get x equals 14. So my x-intercept is 14. And as a point, I'm going to write that as 14, comma 0, right? The 14 is what we solved for. The 0 is what we subbed in. Y-intercepts, we're going to sub 0 for x. So that's going to be 2 times 0 plus 7 times y equals 28. And the 2 times 0 it's 0, so it goes away, and we're left with 7y equals 28. We're going to finish solving that, and we get y equals 4. So the y-intercept is 4. As a point, we're going to write that as 0, 4. Again, it's the y is the 4, the 0 is the x. Now, algebraically, this is what we've done to find the two x and y intercepts. Okay, so if it just says find the intercepts, that's what we need to be able to do. But if you want to take that onto a graph, you can now take these 2 points. There's 0, 14, and here's 0, 4, and that's the line that it's going to create. So we have the 2 points, we can connect them with a line. So algebraically, we can just find those 2 points. We sub 0, right, to summarize what we're doing here. To find the x-intercept, we are subbing 0 in for, I'm gonna highlight it in green, right? We're subbing 0 in for y. Okay, that's finding the x-intercept. And when we're doing the y-intercept, we're subbing 0 for x. And then we're just doing that solving that we've already done. We're solving the equation that we've already done. And then to graph it, we simply take our point, and then we plot it. And then we take our other point here, and we plot it. And then we connect the two with a line. Okay. Let's do something in context now. We are helping to plan an awards banquet for our school, and you need to rent tables to seat 180 people. Tables come in 2 sizes. Small tables seat 4 people, and large tables seat 6 people. So we need to create an equation that models this situation. So let's make sure we understand the situation here, right? We've got a big old awards banquet going on, and we need to seat 180 people. In that awards banquet, we've got some tables that seat 4 people, and we've got some larger tables that seat 6 people. And so we've got all of these tables in here. I'm just drawing a picture of the situation, right? And we need all of these tables to seat a total of 180 people, right? That's what we need to do. All right, so how can we model that? All right, we need 180 people to be sat, right? So let's look at this. Let's look at it this way, okay? So on one side of our equation, we need to come up with a way to model the people sat at tables. People, did I spell people right? I don't think I did. I don't think people has an A. It's an O. People? I don't know. People at tables. We need to find a way to model the people at the tables, and then that has to equal total people, right? We have to seat 180 people. So that's my total people. And then we need to model the people at the tables. All right, so we've got 4-seater tables, and we've got 6-seater tables. So if I had 2 4-seater tables and 6 6-seater tables, how many total people would I seat? Well, that would be 8 people here, and it would be 36 people there. Now, I can change the number of 4-seater tables I have, and I can change the number of 6-seater tables I have. And like this is now going to be 4, and this is now going to be 18. But notice that there's a constant in these, right? The 4 for the 4-seater tables and the 6 for the 6-seater tables, that's staying the same. So The thing that's changing is the number of tables that I have. Well, if that's changing, that means that's a number that I don't have. So I can have X represent my number of 4-seater tables. And then, I can have Y represent the number of 6-seater tables. So what does that do for us? Let's take a look and just check it. If I take 4 times the number of 4-seater tables I have, and add that to 6 times the number of 6-seater tables that I have, that'll give me the total amount of people that I can see at tables. And I want that to equal 180. So it looks like this equation is going to model it well, right? 4, because these tables seat 4, times the number of 4-seater tables. That's going to tell me the number of people sat at 4-seater tables. And then 6, because they're 6-seater tables, times the number of those 6-seater tables that I have. We want that number to be equal to 180. Okay, great. That looks like a model that's going to work. So let's answer these other questions. What do the X and Y intercepts mean in this context? Okay, so my X and Y intercepts, if I plug in, remember, to find the X-intercept, I'm going to plug in 0 for Y. Well, what does it mean to have 0 for Y? 0 for Y means I have 0 6-seater tables. Which means that my X-intercept means that I don't have any 6-seater tables. That's how many 4-seater tables I'm going to need to cover 180 people. Because if I'm not taking any 6-seaters, that means I'm going to have all 4-seaters. So that's what that means. Conversely, the Y-intercept, well, that means that there's 0 4-seaters, and that's going to tell me how many 6-seaters I would need. If I had 0 4-seater tables, this would tell me how many 6-seater tables that I would need. Okay, so in context, that's what those things mean. That's what my X and Y intercepts mean. Let's see what the next question here is. We need to graph the equation. Okay, so we've got that. 4x plus 6y equals 180. And you know what? Let's go ahead and find my intercepts. What I'm going to do is plug in 0 for x, find out what I get. So that's 4 times 0 plus 6y equals 180, which is 6y equals 180. Dividing both sides by 6 gives me y equals 30, because 30 times 6 is 180. That, by the way, is the number of the number of 6-seater tables that I would need, right? Because if I had 0 4-seaters, I'm going to need 30 6-seaters to make 180 people. All right, let's do the other one. I need 0 for y. So that's going to be 4x plus 6 times 0 equals 180, which is 4x equals 180, which is x equals, let's see, 180 divided by 4. It's not a really easy one. 160 divided by 4 is 40. Add 5 more to that, so it's 45. 45 times 4 equals 180. So that's how many 4-seater tables I would need. And then we simply need to graph that. Let's graph that over here. Do I need to make 45 hash marks this way and 30 hash marks that way? I hope you're all thinking in your head no, because that would be a super silly thing to do. Let's go up by fives. All right, 5, 10, 15, 20, 25, 30, 35, 40, 45 that way. And then fives this way, 5, 10, 15, 20, 25, 30 this way. So that's 30. And that's 45, which means I have a point here at 45, 0, and a point here at 0, 30. There's my line. And every point in between here is a possible combination of number of 4-seaters and 6-seaters that we need to do. But you know what? We'll talk about that on another day. That's all I've got for you today. Got some problems for you to do before you head to your assignment. So, go ahead and get started. Thanks. Oh. Nope. It doesn't work. Hit the mouse button. Hit the mouse button.